Hi guys, in my last video I had done an example based on inverse proportions. In this video I'll be doing another example based on inverse proportions. Now this example is based on speed, time and distance. So before I go ahead with the example, we will first revise the formula connecting these three quantities. Now calculations involving these three quantities become simple when speed is kept constant. So we all know that distance or d is equal to speed into time. From the same formula, if I have to find speed, speed will be equal to, bring t on the other side, distance upon time. And if I am asked to find time, time is equal to distance, leave time on this side, distance, and speed goes to the other side, distance upon speed. Now a helpful way to remember these formulas is to write these three quantities in a triangle. Write d on top and speed here, time here. So if I have to find d, I will cover d, so I am left with speed into time. If I am asked to find speed, I will cover speed, so it becomes distance upon time. If I am asked to find time, I will cover time and I get distance upon speed. Time is equal to distance upon speed. And great care must be taken regarding the units in these quantities. Now if we compare these formulas to direct and inverse variations, in the first case, we can see that in case of inverse variation, we have x into y or xy is equal to the constant k. So if we consider this distance as the constant k, if we keep the distance as constant and take speed as x and time as y, we can see that if for the same distance, if the speed will increase, it will take less time to reach the distance. Similarly, if the speed decreases, time taken will be more to cover the same distance. That is, the distance is kept constant. So we can say that if distance is constant, speed and time vary inversely with each other. And in the second and the third case, these formulas are of the form x upon y is equal to the constant k. So if you see the second formula, if we keep the speed as constant, speed is kept constant, more time, more will be the distance covered. Less time, less will be the distance covered. Distance and time move in the same direction when speed is kept constant. That is, they vary directly with each other. Same is the case here. If time is kept constant, more the speed, more will be the distance covered within the same period of time. Less the speed, less will be the distance covered within the same period of time. Again, if time is kept constant, distance and speed vary directly with each other. So here's our question. A car can finish a certain journey in 10 hours at the speed of 48 kilometers per hour. By how much should its speed be increased so that it can take only 8 hours to cover the same distance? So here in this question, the distance is fixed. And initially it takes 10 hours to cover the fixed distance at the speed of 48 kilometers per hour. Now they're asking us, what will be the increased speed if the car is taking only 8 hours to reach the same distance? So obviously, if the time taken to reach the same place is less, the speed has to be increased. That is, time decreases, speed will increase to cover the same distance. So here, the two varying quantities are, first is the time. Time is given to us in hours. And the second is speed. Speed is given in kilometers per hour. Here we don't need to change the units because both are in, the time units are in hours. So first the car is taking 10 hours at the speed of 48 kilometers per hour. Then it takes 8 hours to cover the same distance. So we have to find the increased speed. So first let the new speed be x kilometers per hour. Let the new speed be x kilometers per hour. Now since it is covering the same distance in less time, that is, the time decreases, so the speed has to increase. So the time and speed here are showing a case of inverse variation. So here we know that since less time, more will be the speed. So this is a case of inverse variation, that is, therefore variation is inverse. In case of inverse variation, we know that x1 y1 will be equal to x2 y2. Now we substitute the values. What is x1? x1 is 10 and y1 is 48. 10 into 48 is equal to x2 is 8, y2 is x. 8 into x. So therefore the value of x will be, we bring 8 down. 10 into 48 divided by 8. 8 ones are 8 six are. So x is equal to 60 kilometers per hour. Now x is the new speed. But they are not asking us to find the new speed. They are asking us to find the increased speed. So earlier the speed was 48 kilometers per hour. So the increased speed is new speed minus the old speed. That is 60 minus 48, which is equal to 12 kilometers per hour. So I hope this example was clear to all of you. Take care. Have a good day. Bye.